Hi everyone. Again, one of the question was asked in gate array space for 1 mark. And again, this question is from my favorite topic, linear algebra, right? So I think anybody can do it, but what is the first reaction that you have to, you have to showcase is whenever you see the system of linear equations. So first of all, you have to see how many equations are there and how many variables are there. If number of equations and number of unknowns are same or number of variables are same, right, then you can say this is a balanced equation, right? So all kind of solutions are possible, like it can have unique solution, it can have no solution, it can have infinitely many solutions, right? So what we can do now is you will have to write the you can say that you have to apply the elimination, and based on the elimination you can solve this question, right? So finding the, if there will be a free variable, okay, then there will be infinitely many solutions, okay. So let us write the matrix here. So matrix is going to be, this is nothing but ax equal to 0, okay, kind of equation, okay. So you can just take the coefficient matrix. So 7 minus 3 1, and this is 3, you can say this is minus 1 1, and this is 1 minus 1, and minus 1 here, right? Okay, I hope this makes sense, right? So you have to apply just elimination, right? So just we are going to apply the concept of elimination, okay, elimination. So we have to find whether there is a, whether there is what, whether there is you can say that okay, whether there is the free variable or not. If there is a free variable, it means it will be having the, you can say infinitely many solutions, okay, fine. So I think you are not able to see this, so I can just yeah, fine. So now you can apply elimination, okay. So better what you can do here is you can switch this, you can write 1 minus 1 here, okay. You can switch r1 and r3, right? So first one is you can switch r1 and r3, no harm will be there. You know that, suppose this is first equation, second equation, third equation. So if you write third equation on top of that, right, if you exchange equation in the solution, nothing is going to happen. That I have already emphasized in my classes, right? So that you have to understand, if we are switching equations, right, nothing is going to happen with the solution. But yes, if you are computing the determinant, so if you are switching equations, right, so there will be some changes, like some minus changes will be there, right? So this is one important fact, like whether you consider equation third as first equation or equation first as third equation, doesn't matter, right? As far as you are computing the solution of the system of linear equation, right? So you can just switch it. So it will be nothing but 1 minus 1 and 3 minus 1 1, and this is 7 minus 3 1. Now you may be thinking, sir, why you have done like this? So that you can apply elimination properly, because if you choose this as a pivot, right, you can choose this as a pivot, okay, and now you can apply the row operation, right? So I just want to make this is a pivot here, okay. And these procedure I have discussed in the class, how to apply elimination and all. So you have to first choose the pivot, okay. Choosing pivot here is one, right? Pivot must be non-zero, right? And now you have to make below the pivot all element 0, right? So how can you make this 3 as 0? So you can just multiply, you are applying row operation on r2, so r2 minus, you can say 3 times of r1, and you have to also make this guy 0, so you can apply operation on r3, that is r3 minus 7 times of r1, right? Just do this first, okay. So you're going to get first row is gonna be same because you are not applying any sort of row operation, ठीक है, ये तो -1 ही रहेगा, and then ये हो जाएगा 0, right? And you are applying -3, multiplying -3, okay, and subtracting from the second, so this is +3 then, right, because -1 is already present, and then -1 plus 3, that is nothing but 2, right? Okay, and again if you are multiplying -3 here, so it is 3 only, and this is 1, so 1 plus 3 which is 4, ठीक है, and ये तो 0 हो जाएगा, ठीक है. Now -7, so it is +7 -3, that is 4, okay. And again what you're doing here is you are just multiplying, okay, you are multiplying this by -7, so it is 7, so 1 minus 7 is nothing but 1 minus 7 is nothing but -6, right? Okay. Let me check again. So yeah. So if you're multiplying minus 7 with this, okay, so it is nothing but plus 7, and this is nothing but 1. So 1 plus 7 is nothing but what? 8. Not okay. Please be careful about calculation. Now you can observe that something is very important here. You can observe that this is row 2 and this is row 3. So if you say that R3 is going to be what? Now you choose this as a pivot. So this was pivot now. So now you can apply row operation on R3. So which is nothing but R3 times 2 times of R2, right? So your next matrix is going to be what? And two rows are same only, right? They are proportional to each other, right? You can see. So 1 minus 1 minus 1, and this is 2 4, and this is 0, this is 0, and this is 0, right? So you see one of the row, so this, suppose this is x1 x2 x3, right? One of the row is what? Completely 0, right? So here there is a pivot, there is a pivot, but there is no pivot, right? So you can say x1 and x2 are the basic variables, right? And x3 is nothing but your free variables. So if there is a free variable, right, certainly there will be what? There will be infinitely many solutions, right? So in this question you have to just claim that whether there is a many solutions or not. Okay, so in this question infinitely many solutions is the right answer, okay, as long as there is a free variable, understand. But if they ask what is the solution, what in terms of free variable, then we can find out, but that is not needed at this moment, right? Okay. So I hope how to apply elimination you know, right? Okay. So wherever the pivots are present, so those columns, those you can say variables are considered to be basic variables or dependent variables, you can say. And wherever no pivots are present, so that variable corresponding to that column is going to be the free variable. And free variable can also be found out by computing n minus r, right? So order of the matrix, that is 3, and rank of the matrix is 2, because number of pivots are 2, right? So one free variable will be there. Okay, there is one free variable. So I think this is clear. The option for this question is A. Thank you.